Is this linear or nonlinear? Linear, and why? Right. Because look at our definition. It's not a vertical line. It is a non-vertical line. It is a non-vertical line, so it is indeed linear. What about, is this a linear function?
Yes, it is. No.
What do you think? Is it a line?
But it's not vertical.
It can't be vertical. What do you notice about this that's different than the other line? It's curved. So here's the thing. It cannot have a curve. A linear function will not be curved in any way. It will be a straight, non-vertical line. So this is non-linear. It's a function, right? It passes the vertical line test, but it is not a linear function because that's not a straight line. You should be able to line a ruler up next to a linear function.
I guess you could line a protractor with that.
That's true. Protractor, yes, but not a ruler. A straight line.
And it passes the vertical line.
Correct. Exactly. So this one is non-linear because it is not a straight line. So anytime there's a curve, it's not linear. Any kind of curve is not linear. Okay? What about? Yeah.
Yes.
Yeah. Is this a linear function? Yes. Because it is a horizontal line, that's fine. What can it not be? Vertical. Horizontal? Fine. So yes, this is linear.
But it doesn't pass the test.
It does. Draw a vertical line through any point in that graph.
Oh.
Does it go through only one point? Yes. So it is indeed a function and is indeed a linear function. Because we could put a ruler up to it and the ruler could run right along that function. Okay? A couple other ones. These aren't in my original notes, but I just want to show you this. Oh, no. I want to add a slide.
Up and down. What is it?
Straight up and down would be not a function. It would not be a function. Because it wouldn't pass the vertical line test. Okay, let's see here. I need to add a slide, but I can't figure out how to do it. So we said there can't be a curve. There also can't be a point. So like a function like this. So let's say you have a function that looks like this. Okay, this is non-linear. You can't have any curves or any points in a linear function. It can only be a straight, continuous line. If we lined a ruler up next to this, we'd have to move the ruler in order to follow the function, and that means it's not linear, right? So this one would also be non-linear. So watch for points, right? Corners and curves. Those are all non-linear. Linear has to be a straight, non-vertical line. A constant rate of change, meaning the x values are changing at the same rate and the y values are changing at the same rate. If they are, then those points are part of a linear function. So we'll look at what that looks like. Example 2. So here's what it's going to look like. They're going to give you a chart and they're going to say, do these points represent a linear function? Why or why not? And then we have to look at the rate of change. So you'll be given a set of x values and a set of y values. All right, here's our first point at 336. And then our second point is 6:30, 9:24, and 12:18. And what they're going to ask is this linear or nonlinear? Oh, hold on. I want to go back. I didn't know that went there. Okay. So linear or nonlinear, what we are looking at is how the x values relate to one another. What is happening from one x value to the next?
It's doubling. Oh no, that 3 is getting out of each number.
Plus 3, right. Plus 3, plus 3, plus 3. Do you see that? So the x value is going up by the same amount. In order for this to be a linear function, the y value must also have a constant rate of change. It doesn't have to be going up by 3, but it has to be going up or down by the same amount
Going down by 6.
each time. So what's happening between each y value?
Going down by 6.
Minus 6, minus 6, minus 6. So because this is constant up top, I need to make that smaller, and constant down on the bottom, we can say that this represents a linear function. So what they would ask is it a linear function? Yes, because there is a constant rate of change. That means the x is going up by the same amount or down. I mean, you could be subtracting. And the y is also going up by the same amount every time. So when they say y, it's because it is a constant rate of change. Let's look at another one. All right, here's another table of values, x's and y's. We have 1, 2, 3.5, 9, 6, 20, 8.5, 35. So we need to figure out, is this a linear relationship? Let's start with the x's, bless you. What is happening from one x to another?
2.5 is getting out.
Plus 2.5. Plus 2.5. Plus 2.5. So far, so good. The x is increasing by 2.5 every time. Let's make sure that the y's are also increasing or decreasing by the same amount every time. What happened from 2 to 9?
It went up by 7.
Good. Plus 7.
Plus 11.
Uh-oh. Plus 11.
Plus 15.
Okay. So is this a linear function?
No.
No. This is not linear because it is not a constant rate of change. Because the y is not going up or down by a consistent, exact same amount every time. Yes. 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 Does that make sense? So the graph and then the table, whether or not it's a constant rate of change, you're just looking how the points are related to one another. Be a linear function. This is technically the definition. They must be able to be written in the form y equals mx plus b. You've seen this before. Yeah. Where m and b are constants. So y equals 3x plus 2 or something.
But that's not a constant then.
Yes. Well, yeah, m is, well, 10 was a coefficient, I guess, technically. But they're numbers, so m doesn't stay m and b doesn't stay b. They get replaced with numbers. You remember what these represent?
Something slope and line.
Yeah, slope and intercept. But we'll talk about this in the next chapter again, too. So if you don't remember, that's fine. But they have to be able to be written in this form, y equals mx plus b, where y is by itself, x is next to a number. And that's it. If you mess with the y or you mess with the x, it becomes nonlinear. So it has to be y by itself, positive, whole, and x with a coefficient, and no exponents or anything like that. It's easier to understand right now in terms of what there can't be. So if you see any of these things in the red box, it's not a linear function.
Why is there a red box?
I'll show you. These are the things that cannot be in a linear function. You cannot have square roots with an x underneath. If you see an x under a square root, that is not a linear function. Okay? If you see an exponent that is a variable, so for example, 3 to the x, that is not a linear function. Oh, wait. Okay, so no variables in your exponent place. You cannot have variables in the denominator. So 2 over x, this got a little smushed. But 2 over x, that's not a linear function because the x is in a denominator. That's not okay. So no variables in denominators. These are different kinds of functions, but they're not linear. And we're just talking about linear functions right now. Okay, you cannot have exponents other than 1 on your variable. So if you have x squared or x cubed or x to the 4th, that is not a linear function. Bless you. Only x, which is x to the 1st. Okay, so no other exponents besides 1 on your variable.
So couldn't you just have it
Yeah, you can only have x. Okay, same thing if you have like x to the 5th. Anything other than 1 is nonlinear. So only x. Can't be taken to another power. And it can't be in all these weird positions. It can't be in a square root. It can't be in a exponential position. It can't be underneath a denominator. Well, those are all non-linear functions. Or non-linear. We are just looking at written out functions to determine if they're linear or non-linear. Example 3, I think there's a few different ones that come up on this. The first one is y equals 3.8. If we were going to graph this, y equals 3.8, how would this look?
Well, on the y-axis.
No matter what x equals, y is always going to equal 3.8. So what's it going to look like, Zegan?
You're going to go to 3.8 on your graph.
Uh-huh.
On the y-axis.
Yep.
And then put a dot there.
Yep.
And then, that's kind of it because they don't really tell you what direction it goes.
It's actually going to be a horizontal line.
How would you know if it's not diagonal though?
Because any x value that you put in here is going to always have a y of 3.8.
What? Oh.
So it's a horizontal line.
I see.
We might need to talk about this further.
So Max, it's always going to be on either side of 3.8. It's still going to be on that big.
So here's what it's saying. If you make a little function table, right? We plug in our x's and our y's. If we pick any value for x, what this is saying is that y is always going to be 3.8. So then any point you plot, you go anywhere x, you always have to go to 3.8y. So it's just going to be a horizontal line that's parallel to that x-axis. So is this y equals 3.8 linear or non-linear? Linear, right? Because the graph is a non-vertical line. So this is linear.
So if it were to be vertical,
It would be non-linear, not a function. What about this function? Y equals square root of x minus 1. Non-linear, why?
because there's no square roots.
Good.
Freaky, I bet.
We cannot have any square roots with a variable underneath. So that would be non-linear. What about this one? Linear or non-linear? 5 to the x. No.
You can't have 5 in the exponent. Wait, no, you can't have the x.
Right. So basically, if you see exponents with the variable anywhere, if the variable has an exponent or if it's as an exponent, no variable exponents. So this is non-linear. What about this one? Y equals 5 over x minus 1. Linear or non-linear?
It is non-linear.
Non-linear.
You can have an x as the,
Good. Non-linear.
Good dog.
No x. in denominator.
Muji and Van.
6 times the quantity, x plus 1. Is this linear or nonlinear?
Linear?
Why? Why was
How
it-
come?
Yeah,
Because
it's linear.
you never said anything against that.
Right. You didn't say anything against that. Remember, we always wanted to be able to take this form, y equals mx plus b, where m and b are numbers. If we distribute this in,
Said 6x.
we get y equals 6x plus 6. Does that take that correct form of a linear function?
Yeah.
Yes. So this is linear. Yes. We don't have any x's in the denominators, we don't have any square roots, we don't have any exponents, and a lot of times that can help you narrow it down to the fact that it is a linear function. What about this? X squared minus y equals 0. Linear or nonlinear?
It's non-linear because you can't have a number more than one as that.
Very good. Nonlinear because we cannot have an exponent larger than 1 on our x or on our y.
But it's also x and y are in the same.
They're on the same side. And if we separated, like got the y by itself, it would still not be in that y equals mx plus b because we'd have that exponent. Yes, Danny.
Wait, so can the exponent be negative?
Talked about domain and range. So discrete domain and discrete or continuous domain. Remember a discrete domain, what does the function look like if it is discrete? Do you remember this? You can look back in your notes. What do they look like if it's discrete?
Oh shoot.
Look back. There were 2 different kinds of domains and ranges we did. Some we did as inequalities. Some we did as separate points. What did discrete mean? Yeah. Good. Discrete domain was where we had separate points. Remember, they weren't connected. They were just all different little points on the graph. That is discrete. Okay. And what this really means is that for a discrete domain to happen, it means that the independent variable can only be certain numbers. So notice they're not connected. It's
That's why
in
we
this
have
case,
inequalities.
yes, right, for continuous. These are discrete. Okay, so the graph is only at certain point. In this little picture, you're only at the whole numbers, right?
You can just read on the board real quick.
Yes,
We already have this in our notes from last time.
you kind of do, but this is the key that we didn't have before. In a word problem, you'll know that a domain is discrete because the independent variable will not be able to be broken into smaller parts. So the way that we determine discrete domain, if we're not given a graph, is you're looking at that independent variable. And I'll show you an example on the next slide to see how we figure this out. It will be in a word problem. That's the only way that you figure this out if it's not given. Okay? Otherwise, discrete domain doesn't happen. If you're given a function, it's always continuous unless it's a word problem, then it might be discrete. And we'll talk about how that looks. It happens when the independent variable cannot be broken into smaller parts in a word problem. An example of what would be a discrete domain. For example, it says the linear function y equals 15.95x represents the cost y, so y is our cost, of x tickets. Now, in order to determine domain, we're always looking at the independent variable. Which one of these is the independent variable?
15.8.
The amount of tickets.
Correct. The amount of tickets. This is our independent variable. Right? Because you can buy however many tickets you want, and that will give us the cost. So the cost depends on the tickets. Tickets is independent. Let me see if I wrote anything else on this slide. Then it says, okay, so this is like kind of what you would see on your homework. It says you can buy a maximum of 4 tickets. So they're going to limit this for you in terms of how high it can go. You're not going to buy more than 4. Part A asks us, is this discrete or continuous? And again, because this is a word problem, this is why we are asked about discrete or continuous. We're not given a graph here. We can't see if it's points or not. So we have to determine it from the word problem. Look at our independent variable, tickets. Remember what we said. Discrete domain means that the independent variable cannot be broken into smaller parts. Can you break tickets into smaller parts? If you're going to a movie, can you buy a half ticket? No. So this would be an example of discrete domain because you can only buy 1, 2, 3, or 4. You cannot buy 1.75 tickets. You have to buy only whole numbers. So that is a discrete domain. Does that make sense? Zegan?
If you were to graph this, would it be on the y-axis of 15.95, and then x, would there be, what, 4 dots of x?
Correct. Yes. Yes. And I think we do graph it. We'll graph it.
Well, I get how it is discrete,
Uh-huh.
but could it be continuous because it's time, so each time 15 gets larger, it's getting
Yes.
value to 15.
Correct. Your y is going to get larger, but you can't put in any other values for x except whole numbers. Do you see
They
that?
also limit you at 4 tickets, so.
It'll be just, discrete will be just whole numbers.
Continuous can be
Like anything. So continuous could be like hours, right? Can you break hours into smaller parts? Sure, you could work a minute. You could work a second, right? You can break time into smaller increments. You can't break tickets into smaller increments. You have to buy 1 ticket or 2, not 1.9775 or whatever, right? So like that's why it has to be whole numbers. So we say that's a discrete domain because of that independent variable of tickets can't be broken into smaller parts. Okay, then they ask you what is the domain. So the domain is what values could we have of x? There's only 5. What is the domain? How many tickets could we buy?
4.
Or,
Less.
yeah, or less, but
Then equal or equal to.
Less than or
yes, but can we go less than 0?
No.
No. So what's our domain?
0 to 4.
Yeah. So we would say x equals 0, 1, 2, 3. Because it is discrete, we list them one by one.
Because they're not a line, it's a specific point.
Because we can't buy anything in between those whole numbers. We can only buy 0, 1, 2, 3, or 4 tickets. We can't buy anything in between.
Okay, so no brackets or
No, not for discrete. Not for discrete. You have to actually give the point. So, then, what is the range? If this is our domain, let's graph these. So yes, Zegan, if we put this is tickets. This is our x, and then this is our cost. If you buy 0 tickets, how much do you pay?
$0.
0. Okay, so we'll have a point here at 0, 0. If you buy 1 ticket, what'd you pay?
$15.95.
Good.
So it's one of those line thingies. Wow.
If you buy 2 tickets, what do you pay?
Like 30 something plus change.
Yeah, 30.
31 points.
This is not very mathematical. 30-ish. If you buy 3 tickets, how much do you pay?
Some like 45-ish. 45, 95.
Right. Oh gosh, I'm writing these all wrong. 2, 3. If you buy 4 tickets, you're paying what? 60 something. 60 plus.
$60 for 4 tickets. What kind of movie are you seeing? That's an expensive movie.
I don't know.
I feel like a lot of tickets are really expensive.
So then your range, you guys, if the domain's if the domain is discrete, the range is also discrete because these we can't connect these. Why not? Because is there any way that you could buy a ticket that is between 0 and 1? No, right, exactly. So your range then is also discrete. It would be each of these points. Y equals, wait,
1/2 ticket for every 2 tickets. You use 1/2.
0.95, and then whatever it would be, 31 point something, whatever those are going to be. I feel like it's going to be like 62, whatever. Okay, so when it's discrete, you put the points. And we know it's discrete because it can't be broken into smaller pieces. Versus, and you don't have to write this if you don't want to. Make it bullet points. But we've talked about this. The difference is continuous domain is connected. Right? On a graph, it would be connected. It is a line. And the way that we know this is in a word problem, the independent variable will be able to be broken into smaller pieces. So something like time or money, or I think the example that they're going to give is like calories, or
Peanut butter and jelly sandwich.
like you can break stuff into smaller pieces. You can't break tickets into smaller pieces.
But you can break like sandwiches.
Exactly. Yeah, I think that's what it's something with food. I feel like this example, it's like an energy bar or something. So like, could you eat one bite? Yes. Could you eat one crumb? Yes. Could you eat half the bar? Yes. So it can be broken into smaller pieces. So we're always looking at the independent variable. That's our key in determining domain. Is like, is that independent variable something that can be made smaller? If it is, it's continuous. If it can't, if it has to be whole numbers, it's discrete. Example of continuous domain. An anteater consumes 35 insects per day. Write a function that models this. And I don't know. All right. First, we're going to write a function that models this. This is per day, so we're going to call that our x. And then we're going to call y the total number of insects this anteater consumes. How would I write this as a function? Y equals what?
Y equals 35.
Yep.
I thought an anteater was two different words.
35x.
Uh-huh.
Okay. What's our independent variable here?
The days.
The days.
Oh, my days found.
The days. Independent variable is the number of days, right? Is the independent variable something that can be broken into smaller parts? Yes. Can you break days into smaller parts? Yeah, you can. Days can be broken into hours, which can be broken into minutes. It can be broken into seconds, right? So you can break down the amount of the amount of days that you're putting into this function, right? If it's been 1 hour in the day, can you break that? Yeah, sure. If it's been 1 minute in the day, can you break that up? Sure.
What comes after mil?
Right?
Because mil is thousands.
So on the millisecond? Sure. So on the vertical, it'll give you the problem.
It'll say, is it discrete or continuous? Yes.
Is there any other thing that it could be?
No. No. Discrete or continuous. So this one is continuous because days can be broken into smaller parts. Smaller parts, such as hours, minutes, seconds, etc. So it is a discontinuous domain. Okay, so then it's going to ask you to graph. And we're going to do this just sort of like we did the other one. Is this going to go below 0?
No.
No. It cannot eat less than 30. You can't, it's not like, getting rid of them. So this is the number of insects. Or sorry, the number of days.
Why are you awkwardly snapping at me? I took that offensively.
All right, let's graph this. You guys watch up here because you're going to see this come up on the homework and everyone will be so confused.
I'm already.
All right, after 0 days, how many insects does it eat? 0 days. 0. What do we call this point? The origin. Okay, after 1 day, how many insects does it eat? Good. Okay, 270, so on and so on. 3, 115, 105. Gosh, if I could write. And this graph will be what? Is it going to be points? No, it's going to be this.
Wow, that's crazy.
right? It's going to continue, and they're all connected because we could be talking about half a day. We could be talking about 1/24 of a day, right? 1 hour or whatever. So this is continuous in our domain. Okay, so if we were going to describe the domain, we would say that x is greater than or equal to 0, right? Any amount greater than 0 is part of this domain because it could eat for however many days.
What a hungry hippo.
And the range would also be y is greater than or equal to 0. Greater than or equal to that 35 insects per day, starting at 0.